What if a machine could think, learn, and react just like a human? This is the fascinating world of artificial intelligence. Artificial intelligence, or AI, is essentially a field of computer science that aims to create machines or software that mimic forms of human intelligence. Now, it's crucial to understand that this doesn't mean creating an exact replica of the human mind. That's a whole other can of worms. Instead, AI is about creating systems that can perform tasks that would typically require human intelligence, such as learning, understanding language, recognizing patterns, problem-solving, and making decisions. To better grasp this concept, let's consider a little critter from the insect kingdom, the digger wasp, Sphex ichneumonius. This wasp has a very specific behavior. When the female wasp returns to her burrow with food, she first leaves it at the entrance, goes in to check for intruders, and then, only if all is clear, carries her food inside. But here's the kicker. If you move the food a few inches while she's inside, she'll come out and repeat the whole process from scratch, no matter how many times you do it. This behavior, while complex, is entirely instinctual and doesn't adapt to new circumstances. And that's where it differs from intelligence. Intelligence, as we understand it, includes the ability to adapt to new situations, to learn from experiences, and to alter behavior based on that learning. And that's what artificial intelligence strives to achieve. AI systems are designed to learn from their experiences and adapt their behavior accordingly. They're not just following a pre-programmed set of instructions. Instead, they're using algorithms to analyze data, learn from it, and make informed decisions. So, artificial intelligence is all about giving machines the ability to seem like they possess human intelligence. It's about creating systems that can not only perform tasks, but also learn and adapt just like we do. And that, my friends, is the captivating mystery and promise of AI. Imagine a computer program learning from its mistakes, much like a child does. This is what we call learning in AI. Diving into the heart of artificial intelligence, let's explore how these smart systems learn. Just like us humans, AI can learn from its experiences, and it does so in a way that's similar to a method we're all familiar with, learning by trial and error. Picture this. You're playing chess against a computer. The AI doesn't know the best move to make, so it tries one at random. It might lose the game, but it's not all in vain. The AI stores this experience, remembering the move it made and the outcome that followed. This is the essence of trial and error. Ever wondered if machines can reason? Well, they can in a way. Reasoning, at its core, is the ability to draw inferences appropriate to a given situation. And yes, this is something artificial intelligence is capable of. But how does it work? Well, let's dive right into it. In the world of artificial intelligence, reasoning can be broadly classified into two types: deductive and inductive. Let's start with deductive reasoning. This is when the truth of the premises guarantees the truth of the conclusion. For instance, imagine an AI system that's been told, all birds can fly, penguins are birds. The system, using deductive reasoning, can conclude, penguins can fly. However, this is where the limitation of AI reasoning becomes apparent. As humans, we know that despite being birds, penguins can't fly. But the AI system, relying purely on logic, doesn't have that extra bit of real-world knowledge. This is a perfect example of how machines reason differently than humans. Now, let's look at inductive reasoning. This is when the truth of the premises lends support to the conclusion, but doesn't guarantee it. Let's say an AI system has been processing weather data and noticed that whenever the humidity is high and the temperature drops rapidly, it rains. So the next time these conditions are met, the AI predicts rain. This is inductive reasoning, making a general rule based on specific observations. While it's impressive that machines can reason this way, it's worth noting that inductive reasoning is inherently uncertain. The AI system might predict rain based on past data, but that doesn't mean it will definitely rain. There may be other factors involved that the AI isn't aware of or can't account for. So, while artificial intelligence has the ability to reason in a sense, it's not quite the same as human reasoning. AI reasoning is based purely on data and logic, without the nuances and complexities of human understanding and intuition. While machines may not reason like humans, they can use data and logic to draw conclusions. problem solving isn't just a human trait, AI can do it too. Artificial intelligence, or AI, is not just about learning and reasoning, it's also about solving problems, sometimes even more efficiently than humans can. But how does AI solve problems? Let's delve into that. In the realm of AI, problem solving is often characterized as a systematic search through a range of possible actions to reach a predefined goal or solution. This might sound a bit complicated, but let's break it down. Imagine you're in a maze and you need to find the exit. You might start by randomly choosing paths, then gradually eliminating the ones that lead to dead ends until you find the exit. AI uses a similar approach, but it does so in a more organized and systematic way. AI problem-solving methods fall into two main categories: special purpose and general purpose. Special purpose methods are tailor-made for a specific problem. They exploit very specific features of the situation in which the problem is embedded. For example, a chess-playing AI might have a special purpose method to solve a particular chess problem, using knowledge about the specific arrangement of pieces on the board. On the other hand, general-purpose methods are applicable to a wide variety of problems. These methods are more flexible and adaptable. They don't rely on specific features of a problem, but rather use broad problem-solving strategies that can be applied to many different situations. For instance, a general-purpose method might involve systematically trying out all possible solutions until the correct one is found. In problem-solving, AI can be incredibly efficient, often outperforming humans in speed and accuracy. This is because machines don't get tired, they don't lose focus, and they can process information much faster than we can. However, it's important to remember that while AI can be a powerful problem-solving tool, it's not infallible. AI is only as good as the data it's trained on and the algorithms that drive it. It can't think outside the box or come up with creative solutions in the same way a human can. Machines can be programmed to solve problems using either specific or general approaches. But the beauty of AI lies in its ability to learn, adapt, and improve over time, becoming an ever more efficient problem solver. AI isn't just about thinking and learning, it's also about perceiving and understanding language. Imagine the world around you as a complex, ever-changing puzzle. Each piece of the puzzle is an object, a person, an event, and they all interact in various ways. This is the world artificial intelligence must navigate. In order to do that, AI uses perception. Perception in AI involves scanning the environment with virtual or artificial sensory organs, and breaking down the scene into separate objects in various spatial relationships. The challenge here lies in the fact that an object might appear different based on the angle from which it's viewed, the direction and intensity of illumination in the scene, and the degree to which the object contrasts with its surroundings. This is a complex task, and yet, AI is making strides in this area, learning to perceive and understand the world around us in a deeply intricate way. But perception is just one piece of the puzzle. Another key aspect of AI is language understanding. You see, language is a system of signs with meaning, and these meanings are often agreed upon by convention. This isn't limited to spoken or written words. Think about traffic signs, for instance. It's a matter of convention that a triangular sign with a red border means warning or hazard ahead. AI, too, can learn to understand these conventions. It can learn to recognize that certain signs or symbols carry specific meanings, and it can use this understanding to interact with the world more effectively. It can understand instructions, respond to queries, even engage in conversations. The beauty of AI lies in its ability to mimic human capabilities, to perceive the world around it, to understand language, to learn, reason, and solve problems. As AI continues to evolve, the possibilities are virtually limitless. AI has the potential to perceive its environment and understand language in a way that mimics human capabilities.